So what is climate? Climate is the average weather in an area over a long period of time, whereas weather is a day-to-day explanation. Weather and climate are described in terms of factors like temperature and precipitation. The climate of a particular location depends on its latitude, the distance from the equator, and its altitude, the distance above sea level. Other factors that affect an area's climate include its location relative to the ocean or mountain ranges. The temperature on Earth's surface falls from the equator to the poles. Based on temperature, climates can be classified as tropical, temperate, or Arctic. Temperature also falls from lower to higher altitudes, for example, from the base of a mountain to its peak. This explains why the tops of high mountains in tropical climates may be snow-capped year-round. Coastal areas may have milder climates than areas farther inland at the same latitude because the temperature of the ocean changes relatively little from season to season, and this affects the temperature on nearby coast. As a result, many coastal areas have both warmer winters and cooler summers than inland areas. So here you can see the temperate zones. You have the equator here that runs in the middle, and on both sides of the equator you have tropical zones. So tropical zone north of the equator, tropical zone south of the equator. And then on either side of the tropical zones, you have temperate zones. So below the tropical zone, you have temperate, and then above this tropical zone, you have temperate. And then on the very tips of the Earth, so on each pole area, you have Arctic zones. So you have an Arctic zone on the top and an Arctic zone on the bottom. Based on the amount of water available to plants, climates can be classified as arid, which is dry, semi-arid, semi-humid, or humid, which means wet. The moisture of a biome is determined by both precipitation and evaporation. Evaporation, in turn, depends on heat from the sun. Worldwide precipitation patterns result from global movements of air masses and winds. For example, warm, humid air masses rise over the equator and are moved north and south by global air currents. The air masses cool and cannot hold as much water. As a result, they drop their moisture as precipitation. This explains why many tropical areas receive more precipitation than other areas of the world. When the same air masses descend at about 30 degrees north or south latitude, they are much drier. This explains why dry climates are found at these latitudes. These latitudes are also warm and sunny, which increases evaporation and dryness. Dry climates are found near the poles as well. Extremely cold air can hold very little moisture, so precipitation is low in Arctic zones. However, these climates also have little evaporation because of the extreme cold. As a result, cold climates with low precipitation may not be as dry as warm climates with the same amount of precipitation. So in this diagram, you get to see the different air masses and their movements. The blue arrows are referring to the moist air masses and the way that they're moving. The red arrows are the direction of the dry air masses. And the black arrows, so these circles here, are going to be the direction of the prevailing winds. We're going to take a few minutes and watch this video about air masses and weather fronts.
Snow day! Ugh. RJ, watch it. Sorry, I'm a little excited for our random day off.
I can't believe there was a snowstorm. It just came out of nowhere.
The snow didn't just come from nowhere. A cold front moved in.
A what?
A cold front. A front is the boundary where two air masses clash, and weather, like snow, occurs. There are warm and cold fronts. I'll demonstrate.
No, don't. Just tell me.
I'm not going to throw it at you. Listen, you know what an air mass is, right?
A big massive blob of air?
Kinda. An air mass is a large body of air that has the same temperature and moisture level throughout. There are 4 different types of air masses in the United States, and each one carries its own temperature and amount of moisture.
So what are their names?
Well, 2 are cold and 2 are warm. The 2 cold air masses are the maritime polar air mass and the continental polar air mass.
What about the two warm air masses?
The two warm air masses are called the maritime tropical air mass and the continental tropical air mass.
So which ones can I thank for the snow day?
It snowed because one of the cold air masses clashed with a warm one and made a cold front. When that snowball hit you, it exploded, right?
Yeah, and it hurt.
Well, Sam, I think it's instant replay time. Let's say the snowball was a cold air mass and you were a warm air mass. When you both clashed together, a front was made and the ball burst. It snowed.
Oh, that's kind of cool.
Yeah, this snowstorm is a result of a cold front. Cold fronts happen when a cold air mass pushes a warm air mass up. Big puffy clouds called cumulus clouds are formed. When you see dark clouds like those, you can bet you're in for some heavy rain, thunderstorms, or a snowstorm like this.
What happens at a warm front?
A warm front happens when a warm air mass catches up with a cold air mass and slowly climbs up and over it. As the warm air mass passes over the cold air, long, thin stratus clouds stretch out across the sky. A warm front can cause rain and snow too, but it's light and steady, not heavy and stormy like a cold front's weather.
So a cold front means pretty crazy weather that gets me a snow day. And a warm front just means it might still rain or snow, but it won't be as intense. An air mass is a large body of air that has the same temperature and moisture throughout, and there are 4 types of air masses in the U.S. Each one has unique characteristics that hint at where it formed. When 2 of these air masses meet, they form a boundary called a front. It can be a warm front or a cold front, but either way, some kind of weather always happens on a front.
Hey! Okay, I deserved it. It's freezing though. I think I'm gonna head in for some hot chocolate.
All right, so when talking about air masses, continental are going to be dry and inland. Maritime are going to be wet and coastal. And Arctic is very cold and dry. So the continental Arctic is the inland dry and very cold air that you find up here north of Canada. The continental polar is inland and it's dry and cold air. Continental tropical is inland, but it's dry and warm air. Maritime polar is coastal, but it's moist and cold air. And maritime tropical is coastal and moist, but it's warm air. So when 2 different bodies of air come together, they do not mix. Each body of air will retain its individual properties and a boundary forms between them. When 2 large air masses meet, the boundary that separates them is called a front. A warm front is where a warm air mass stretches over a cold air mass, stratus clouds form, and steady rain or snow falls. A cold front is where a cold air mass pushes the warm air mass up, cumulus clouds form, and heavy rain or snow storms occur. So how does climate affect the type of biome in an area? Well, plants are the major producers in terrestrial biomes. Almost all other terrestrial organisms depend on them either directly or indirectly for food. Plants need air, warmth, sunlight, water, and nutrients to grow. Climate is the major factor affecting the number and diversity of plants, and therefore animals, that can grow or live in a terrestrial biome. Climate determines the average temperature and precipitation, the length of the growing season, and the quality of the soil, including levels of soil nutrients. In this diagram up here, you can see that the soil profile on the left is from topsoil that's formed from a cold, dry climate, and it's very thin and it doesn't have a whole lot of nutrients. Whereas the one on the right is thick, rich topsoil that's formed in a temperate, moist climate. And then remember, biomes across the world are determined based on their climate, which is based on the latitude and the altitude.